Hi viewers, welcome to all. Here we are discussing about a project, a novel in-memory Wallace Tree multiplier architecture using majority logic gate. Okay, the latency of arithmetic adders and subsequently multipliers that are implemented as succession of such Boolean operations grows or significantly increases with bit width and memory logic. In this study, we address the excessive latency by using a Wallace Tree multiplier architectures and enhancing the addition operations in each step of the Wallace Tree multiplier. This allows us to reduce the latency, memory logic and power significantly. Okay, because this architecture was developed with a majority logic gate using reversible technique. The majority logic primitive was used for the additions of 4:2 compressor to reduce the number of partial product stages in the Wallace Tree multiplier. The proposed work of this design, a majority logic gate using reversible technique using Feynman and Toffel gate and design was proposed with a reversible majority logic gate full adders and a reversible majority logic gate compressor, and proved the comparisons with a conventional majority logic gate full adders and conventional 4:2 compressor. Thus, the final design of 8x8 reversible majority logic Wallace Tree multiplier using conventional and reversible method with 16-bit ladder feature parallel prefix adder. Finally, this work was developed using a Verla HDLs and synthesized using Xilinx Vertex 5 FPGA and compared all the parameters in terms of area, delay and power. Okay, now we can verify the base paper. So this is a base paper title. Here they are planned for Wallace Tree multiplier architecture using majority logic. Okay, so majority logic gates already we are know about that, the majority logic gate using for the quantum component element. Okay, so here the HDL based majority logic gate we are used here. The majority logic gate formula is AB into BC into CA. Okay, so we can use that formula and we can elaborate that majority gate. Okay, so here what we have proposed this paper means we are designed the majority logic gate with using a reversible functionality. Okay, for that reversible functionality we are designed with the Feynman gate and Toffel gate. Okay, so here you can check the architecture of the Wallace Tree multiplications. Okay, so this is a 4x4 Wallace Tree multiplier. So here they are given, right. So initially in the multiplication means we need to generate a partial product. First the partial product generated means that partial product we need to given that to full adder or half adder or compressor. Okay, that is a process of Wallace Tree data multiplier. Okay, and any approximate multiplier method. Okay, but here what they are using means they are design a new technique, the majority gate based full adders they are designed. Okay, so this is a design. Okay, so you can check it. Okay, so this three majority gate they are used to design a one full adder. Okay, so that full adders we are used for whole multiplier addition. Okay, so this is a concept of this paper. Okay, so we have proposed inside of this majority logic gate we are designed with the reversible logic. Okay, so this is a design for 4x4. Okay, and the 8x8 design they are given on figure 10. Okay, so this is a 8x8 multiplication design. Okay, so here you can check the multiplication architecture. So this is a number of partial product based addition. Okay, so here what is the disadvantages means they are used totally full adders. Okay, more number of full adders they are used and they are using stage 1 2 3 4. Okay, the 4 stages it will be taken, and final stage also they are designed with the ladder feature parallel prefix adder. Okay, so we plan to reduce this number of additions and number of partial product additions. Okay, so we are plan to use a compressor 4:2 method. That compressor 4:2 method also designed with the majority logic gate, and that majority logic gate also designed with the reversible functionality. Okay, so this is a design technique for the proposed one. Okay, so this is a multiplication for Wallace Tree multiplier using the half adders and full adders and 4:2 compressor. Okay, so here we are used a half adder, right. That half adder also we have created a novelty based majority gate design. Okay, and so it will take only 2 stages. Okay, this is stage 1 and stage 2. Okay, the third stage we are used with the ladder feature adder. Okay, and this is the existing design. Okay, so for writing purpose we are used this design. Okay, so here we are generated this code in Verla HDL. Okay, so this is a code for reversible method. Okay, reversible method for means 8 cross 8 multiplication. Okay, so this is a test bench of the code. Here this is a top model. Okay, so here we are used a 8-bit multiplication only. So 8 into 8 means 16-bit output. Okay, so this majority gate equation is here. This one is a AB plus BC plus CA. Okay, and we are used the TOEFL gate and Feynman gate for this majority gate design. Okay, and this simulation we have to show it on here. Okay, so here you can check the simulation. 4 into 2 means equal to 8. Okay, 8 into 4 means 32. So the multiplication check for verification purpose we are added, so you can check the data, it will be correct or not. Okay, so you can check all the data. Okay, so the both data of multiplication check and product output will be same. Okay, and you can check, use your calculator and you can check manually. Okay, so what are the values, it will be correct or not. Okay, and the second coding part is this one. This one is a reversible logic method. Okay, without compressor. Okay, so here you can check. So we are not used the compressor here. Okay, so we are used only the full adder method. That simulation output we are given on here. Okay, this is a simulation output for that. Okay, so we have designed the compressor 4:2 and conventional majority gate and conventional majority gate compressor 4:2 and conventional majority gate full adder, reversible majority gate gate compressor, reversible majority gate full adder, and Wallace Tree multiplier 8 cross 8 conventional majority, and Wallace Tree multiplier 8 cross 8 conventional majority gate with compressor 4:2, and Wallace Tree multiplier 8 cross 8 reversible majority, and Wallace Tree multiplier 8 cross 8 reversible majority compressor 4:2. So we are design all this code and we are taken as a comparisons. Okay, in this video file we can't possible to show all the codes. Okay, so here the next thing is synthesis report. Okay, so this is a synthesis report for the Wallace Tree compressor method. Okay, here you can check the number of slice LUTs. Okay, and number of occupied slices, number of IO bits, and synthesis report you can show the delay. Okay, delay will take 9.147, and you can check the RTL schematic for compressor method. Okay, so this is a proposed architecture. So initially we are given an input on here. Okay, here A input, B input. So this input directly given into the partial product generation. Okay, so partial product generation means it's a totally AND gate. So that partial product generated will produce the output A0, B0, A0, B1. Okay, so that output we are given into the half adders, full adders, and compressor. Okay, so here half adder means, okay, here you can check the half adder design with the majority logic gate. Okay, so that majority logic gate also designed with the reversible functionality, TOEFL gate, Feynman gate, and Feynman gate. Okay, and here you can check the full adders. So this is a full adder for reversible majority gate. Okay, so you can check the majority in the full adder. Okay, and the compressor 4:2. Okay, so this is a compressor for 4:2 method. Okay, this is a full adder. Okay, and finally we are designed with the Landner feature adder. Okay, so Landner feature 16-bit adder. Okay, and the second design is without compressor. Okay, so this is a design for the without compressor method. Here you can check the number of LUTs, occupied slices, IO bits. Okay, and you can check the synthesis delay 9.820, and you can check the RTL schematic. Okay, so here this design we are not used any compressor. Okay, here it's totally designed with the full adder of reversible majority gate. Okay, and we are taken all the comparisons. Okay, that comparisons we can show it on here. Okay, it's comparison for full adders and majority full adders and reversible gate full adder. Okay, you can check the full adders part. Okay, this is a conventional full adder using two half adder method. We are compared but that full adder also. Okay, and this is a comparison analysis chart, and this is a comparisons for compressor 4:2 method. Okay, and this is a comparisons for Wallace Tree multiplier. Okay, so Wallace Tree multiplier means we are used with a conventional majority logic gate and reversible majority logic gate, and using only the majority logic gate full adders, and using 4:2 compressor and majority get flooded. Okay, so 1 2 3 4 comparisons we are given for Wallace Tree multiplier, and 3 comparisons for compressor method, okay, and 3 comparisons for full adder. Okay, the total comparisons we are given. Okay, and we are written an abstract document for this project. This is a best paper abstract and announcement of this project. Proposed title, proposed abstract, existing system disadvantages, proposed system advantages, and related notes for this project, and finally literature survey and references. Okay, thank you.
If you need more video related with VLSI projects implementation, please like and subscribe this channel.